Okay, now sort of fresh off of the integrals we looked at, I'm going to apply, again, like the integration by substitution last example, and carry this over to the realm of the physics properties of acceleration, velocity, and distance. And let's say that if we have conditions whereupon we have that a is equal to t times the square root of t plus 2, and we'll say that we have at time t is equal to 2, the velocity is equal to 2, and likewise at the time t is equal to 2, the distance is equal to 1. And I'm sort of cherry picking the numbers here because if I had like 0, I would end up with working with radicals or irrational numbers as opposed to those that are rational. Okay, and so looking at what we have here, so again, acceleration is the change in velocity with respect to change in time. And so I have dv over dt is equal to, again, acceleration, which we have assigned at t times the square root of t plus 2. And looking at separating the differentials, okay, so you have dv is equal to t times the square root of t plus 2 dt. And after separating, we can integrate. And so we have for dv, antiderivative is v. And again, just borrowing from the last integral where we have t as opposed to x. Okay, so the antiderivative terms, okay, we end up having 2/5 of t plus 2 to the 5/2. Minus 4/3 of the quantity of t plus 2 to the 3/2. And we'll say that we have followed by c sub 1. And so we have v sub 2 is equal to 2. Okay, so I have, again, t is equal to 2. And we have initially that v is equal to 2. And substituting accordingly. Okay, so v is at 2. And we have is equal to 2/5. Okay, and 2 plus 2 is going to be 4 to the 5/2. We have minus 4/3. And this will be 4 to the 3/2. Followed by the constant. And so once I gather the terms here, so I got 2 and 4 to the 5/2. Okay, that is going to be a whole number at 32. So we have times 2/5 moving to the other side. So we have 2 minus 64/5. And for 4 to the 3/2, okay, that's going to be 8. And so we have times 4/3, so we have plus 32/3 is equal to c sub 1. And once I gathered the values together, okay, so we're going to have for the outcome in the case of c sub 1, okay, and so that is going to end up as a negative quantity where we have c sub 1 is going to be equal to negative 2/15. And if you notice, you have c sub 1 is negative 2/15, and that does not match up with the value originally assigned for v. Okay, so a lot of cases, especially when the time is at 0, the constant and the assigned value for the distance or the velocity will be the same, but not always necessarily. Okay, so looking at what we have for v in the general case. All right, so we're going to have for the expression, so we got v equal to 2/5 of t plus 2 raised to the 5/2 minus 4/3 of t plus 2 raised to the 3 halves. And again, instead of just c sub 1, we have minus 2/15. Okay. And this expression will be carried over, okay, in creating the pathway to determining the distance in terms of t. Okay. And so we have, looking at what we have for distance. Okay, and again, change in distance with respect to change in time is the velocity. Okay, and I'll just go ahead and put down, okay, what we have defined for velocity in terms of t. Okay, so we have in the setup, okay, so you have dx over dt is equal to this expression, and okay, and once again, we can isolate the differentials. Okay, so we have dx is equal to our parametric expression times dt. And upon separating the differentials, we can once again integrate. And looking at what we have for the antiderivatives. Okay, so we have x from dx, and for what we have for t plus 2 to the 5 halves. Okay, so you got what's going to be 2/7 of this expression to the 5 halves and multiplied by 2/5. So this will be 4/35 of t plus 2 to the 7 halves, and we have minus 4/3, this will be times 2/5, so we have minus 8/15 of t plus 2 to the 5 halves, and we have minus 2/15 of t, followed by the second constant. And looking at what we have, and again, we have for x, whenever t is equal to 2, okay, x is at 1, so substituting accordingly. Okay, so x is at 1, and we have 4/35 of what's going to be 4 to the 7 halves. We have minus 8/15 of 4 to the 5 halves, and we have minus 2/15 times 2, so we have minus 4/15 plus c sub 2. And so just gathering our terms together, and it's going to follow that for c sub 2, that is going to be 389 over 105. So for the result that we have for x, okay, so we have this set of parametric terms. And for what we have in terms of following through, so we have, again, 4/35 of the quantity of t plus 2 to the 7 halves minus 8/15 of the quantity of t plus 2 to the 5 halves minus 2/15 of t, and we have plus 389 1/05. And there's quite a bit of number crunching involved, but I just kind of wanted to use this as a segue to one of our next topics, which will be concerning just one of the foundations in fluid mechanics by the name of Torricelli's law.